Now, this must be one of my busiest drawings ever. Think of it this way. This drawing is split in half, and the bad is over here and the good is over here. We're talking about moisture. Moisture is a problem. Why is water a problem for us? Well, water is a problem because it is necessary for the growth of pests. Pests like mold, mildew, dry rot, termites, dust mites, and cockroaches. And maybe you ask, what's wrong with those types of organisms? Don't they have a right to live too? Well, we've got two problems. First of all, we've got the health of the people in the home. And second of all, we've got the durability of the home. That's what we're interested in optimizing. There are 4 ways that moisture moves around in buildings. And they are the flow of bulk water, airflow, so that we have water vapor in the air, and the air flows between indoors and outdoors, and between indoor spaces and intermediate zones like crawl spaces and garages and attics. Then we have capillarity, and normally when we talk about capillarity, we're talking about water moving by capillary action, rising up out of the soil and pulling its way up through the pores of materials like wood, drywall, concrete. Materials like that can be subject to capillary action. And the moisture is generally coming from the ground, from the foundation around the building. It can rise out of the ground by capillary action or by capillarity. Then we have vapor diffusion, and the water vapor molecule is smaller than air molecules, so it can go through smaller spaces. It can go through paint, through drywall, through concrete, through wood, at a slow pace. This is not a rapid process, vapor diffusion. That's why I have it as number 4, because it's less important than bulk, airflow, and capillarity. These 3 can be a very grave moisture problem. Now, vapor diffusion can be a problem. Where it is a problem is in very cold climates, where you have a very large difference in vapor, in water vapor in the air between the indoor air and the outdoor air. This is during very cold weather. There can be a lot of moisture flow from the indoors to the outdoors or through building cavities where the moisture can condense. That's what our concern is with vapor diffusion. So moisture problems like pests, mold, mildew, rot, termites, dust mites, cockroaches, are related to some type of a source of moisture. This is very important to understand. There's always going to be some kind of source of moisture, and the moisture is going to be able to move around. It can move around in a helpful way in terms of drying out the building, or it can move around in a harmful way in terms of wetting other parts of the building. Let's look at some of the common ways that moisture gets into buildings. First of all, the most obvious is going to be rain. And rain can come through leaks in the roof. A leaky roof is a very, very bad housing problem. It's a problem for health and safety. It's a problem for durability. Then, if we don't have any overhang on the building, wind-driven rain acts on the siding, and we can have problems with rain entering the building through the walls. Then we have runoff along the ground. And if the ground isn't sloped away from the building, if instead it's sloped toward the building, we can get puddling next to the building. And that is a very, very serious problem that occurs in many homes. Also, not only does rainwater flow along the surface of the ground, but it flows through the ground. So groundwater can flow. If we have a hill here that runs into the building, the groundwater can flow underneath the ground, and it can wet the whole area around the building. And when that whole area is wet, well, the water moves by capillary action. It rises up through the building materials. Water vapor comes through the concrete or dirt floor and creates a high relative humidity inside the basement or the crawl space and eventually inside the home. That high relative humidity inside of a home, why is that bad? Well, that creates condensation. And the condensation flows by gravity, just like bulk water flow, and it wets not only parts of the building that are the coldest, which is where the condensation occurs. That's where the condensation occurs, is where the building is coldest. It also runs down and can wet the floor if it occurred on the wall or on a window, ruins window sills and the paint on windows. And so we have sources of water, and then we have the water moves around inside the house by airflow and by capillarity. We have a source of water. We have water capable of moving around inside the building, and that is related to our source of moisture. When we have a moisture problem, when we walk into a building and smell a musty odor, or we see windowsills that have paint chipping off of them, or we see people who have respiratory problems like chronic bronchitis or asthma or allergies. These can all be related to this source of moisture, which encourages the growth of pests. Now, this flow of rain, runoff, bulk moisture entering into the building, either from roof leaks or groundwater or capillary action or water vapor diffusion from the ground or water turning to water vapor at the surface of the floor right here and raising the relative humidity inside the home. These are the most severe problems that you'll find. And if a home has a severe moisture problem, it probably has a problem related to bulk water flow. Now, how do we control moisture? Let's go to the good side of this drawing. One thing that we want to have is we want the building to be able to dry out if it gets wet. And so in the wall, in most climates, we're hesitant to install a vapor barrier. I'm hesitant to tell you that it's good to have a vapor barrier on the warm side of a building unless you live in a very cold climate. And the reason is with a vapor barrier in the wall, if you're air conditioning a building, the moisture can be traveling from the outside to the inside. It can get caught here at the vapor barrier. That's when water can condense and wet the insulation materials and the studs. So if we don't have a vapor barrier, and then there's a number of different types of vapor barriers. You've got vinyl wallpaper, you've got polyethylene vapor barriers. On the outside, steel siding, aluminum siding, vinyl siding are all pretty much of a vapor barrier, although the steel siding and the vinyl siding have drains in them for when they get condensation on the back of the siding, the moisture can drain out of the siding. But we have to be careful about putting vapor barriers in a wall. And the reason why we have to be careful is we don't want the moisture to get trapped in the wall. But there are bigger problems that we need to solve here. One of them is what happens to the rain coming off of the roof. Well, in this picture, we have an overhang, and an overhang is one of the most critical elements of a building in determining how long that building is going to last. The bigger your overhang, the longer the building is going to last. Then we have rain gutters, which can be kind of a pain because you have to clean the dirt and the leaves out of them. But What we're trying to do with a rain gutter and a downspout is we're trying to get the water away from the building. We don't want the water to collect in this area. And if we have serious problems with a lot of rain, if you live in a rainy climate, then we may have to create some kind of a sump here which will help the water to drain away, either by use of a drain pipe or just by the natural percolation of the water into the ground. Here against the foundation, again, we may have some drain pipe. Gravel is very good to have next to the foundation because the water drains through the gravel. And if this pipe is sloped, then the pipe can carry the water away. What we want to do is to encourage the water to drain away to lower ground, to drain around the house and away from the house to lower ground. If we happen to have a problem where we have a water table or water getting into this area down here, we can use a sump pump that will pump the water up and into this area where the drain tile is, or actually pump it out of the house altogether and into some kind of external sump. Another feature to consider for dealing with groundwater is to have an impermeable cap to the ground right next to the foundation. And of course, we would want that cap to be sloped away from the house, wouldn't we? Wood and other building materials can get wet by two basic ways. They can be wetted by liquid water, or they can be in an environment that has a very high relative humidity. Here you see a wood moisture chart. And the chart shows the normal range, normal to dry range of moisture, a borderline area, and then the fiber saturation area where mold is formed. We've got 8% to 14% is normal. That's just the normal percentage of moisture in wood. 14 to 16% is borderline. That's where we're concerned about the moisture level. But when we get above 16%, 16 to 22%, we're coming up toward the fiber saturation point of the wood, where the wood couldn't hold any more moisture. And at that point, we're very concerned. At this point, we have invited the pests into the wood, and we have a real problem. We could have the same kind of a chart for something like drywall. Drywall is very susceptible to moisture. When you get up to about 11%, 10 or 11% with drywall, that's when you start inviting sick building syndrome, mold, mildew, and other types of pests.